So, welcome to my talk, how we made WarehousePG Open Source and what happened to Greenplum. Any one of you know about Greenplum or worked with Greenplum before? That's quite a few hands. My name is Andreas. I'm working with Postgres since around 97, 98, so quite some time. One of the founding members of Postgres Europe on the other side of the world. We also run a couple of conferences like PostgreSQL Europe, PostgreSQL Germany, FOSDEM, and so on. I joined EMC back in 2011 and worked on Greenplum for 10 years. Then I had the database team at a company called Just in Berlin for a couple of years. And now I'm back working on WarehousePG and Greenplum at EDB. Speaking of conferences, we just announced, I have an echo on my microphone, can you? We just announced PostgreSQL Europe in Valencia in Spain. So if you want to come, in a couple of days we open ticket sale. Best way to reach me is actually on my Mastodon or on LinkedIn. I have the QR codes here for you. And I will blog about this conference on my blog. Okay. What are we talking about? I will tell you a little bit what is Greenplum, what is WarehousePG, where does it come from, Greenplum, what problems does it solve, and what is the open source story behind it. Because it was closed source, it was open source again, and then a little bit of an outlook.
No, this is not the
I'm sorry. Okay, let's dive in. At the basics, WarehousePG is a massive parallel, shared nothing, open source of course, hardware agnostic secret database. It's a lot of buzzwords. Massive parallel means we are running a database on more than one server, ideally on like a dozen, 2 dozen servers, and these servers do not share anything with each other. It's a small picture here. So at the top, you see what we call the coordinator host. This is one server, and your application always only talks secret to the coordinator host. For your application, it looks like it's one big Postgres database. Even the version string says it's Postgres. Then we have the network in the middle, where we connect the segment databases on the bottom to the coordinator on the top. And then at the bottom here, it doesn't show, we have one or multiple segment hosts. And each of the segment hosts have their own RAM, CPU, memory, disk, and they don't share anything with each other. So it's not like you have a shared network attached to it, because it would be too slow. You have local disks in these servers. Ideally, more than one, you can spread out the workload. Another thing we do differently than Postgres, each of the database icons on the host shows one Postgres database. So we have multiple Postgres databases running on each segment host. Not something you do typically in a Postgres deployment, but here we actually take advantage of that we have very powerful servers today. So what we do here is we have more than one Postgres database. Let's say in a typical Postgres deployment, you have like 128 CPU cores, and you're running one query. How many CPU cores are you really using? 2, 4, 5 maybe, background workers. What about the other CPU cores? You can't really use them. By running more than one database on the host, we're actually taking leverage of all the resources we have. And we can use more CPU, more RAM, more disk I/O. And then WarehousePG is. In May last year, we forked Greenplum. We named it WarehousePG because the Greenplum name is licensed. There's a trademark on it. And it's under the Apache license. It's kind of similar to the Postgres license. It's also a BSD license. However, the Apache license has a license core on it, so you cannot actually use any kind of trademarks on it. I said it's hardware agnostic, which means you can just buy servers off the shelf, go to your preferred vendor, get a couple of servers, and run your database on it. So you don't have to buy very expensive, very top-of-the-shelf servers. It just runs on your commodity hardware. Of course, the faster the hardware, the better for your database, but it doesn't mean you have to buy today for 3 years in advance. It's SQL compatible, so mostly what we have in Postgres 12, because we are based on Postgres 12, so it's mostly compliant to SQL 92, has a lot of features from SQL 99, and quite a few features from SQL 2003. And again, it looks like a Postgres database to any application. It's, however, not the only fork of Greenplum. So, of course, there's Greenplum in the beginning, and Greenplum itself is a Postgres fork. Then we have a GreenGage database. It's forked by Arena Data out of Russia. There's Cloudberry. It's forked by a company called Hashdata in China, and it's now an Apache Incubator project. We actually looked into if we want to work with Cloudberry before we forked WarehousePG, but quite unhappy with the quality of the code and the deployment happening there. And there's OpenGPDB from Yandex Cloud. These are the three, I would not say competitors, but forks of Greenplum I know. The entire concept of doing shared nothing databases, however, is nothing new, and Greenplum is not the first one doing it. Probably the first one doing MPP is Teradata. You may have heard about it. Back in the 1970s, early 1980s, was one of the first shared nothing databases. There was Netezza, belonged to IBM, it's now end of life. Amazon Redshift, Snowflake, BigQuery, Yugabyte, they all do this shared nothing MPP database. Not necessarily a Postgres fork, but they're all using the same technology under the hood, which by itself shows that if Teradata is around for 40 plus years, this is actually something we can use in the market. Okay. What problems does it solve? What's the largest Postgres database you have? Give me some numbers, please, in terabytes. 30 terabytes? Anything larger? 90. That's quite a size. Okay, you have your typical Postgres database, maybe 10 gigabyte, maybe 100 gigabyte. It nicely fits on one server. But what happens if your server becomes too small? You do not have enough CPU, too many queries, database is growing. What are you going to do? Well, your only choice really is buy a new server. And because a new server is expensive and it takes some time, you actually have to plan in advance for 2-3 years. You have to buy today what you need in 2 or 3 years. So the finance department is not really happy with you. If we go the scale-out approach we have in shared nothing databases, we don't have to buy new hardware every 2 or 3 years. We actually just add a couple more of the same servers we have. And the same servers or same size over time becomes cheaper. So if I buy the first 3 today and the other 2 next year, it's probably cheaper to buy the other 2. And I get the same hardware, and I expand my database, and everything becomes faster. Coming back to this picture. So we scale out, which means in the big picture we have more segment hosts now. Let's say we had 3 in the beginning, and now we have 6, which means instantly we double the CPU we have, we double the RAM we have, we double the I/O size we have, and we halve the query time. Because now every query runs on double the amount of resources we have. So if your query was like 2 minutes before, it's 1 minute after the expansion. Because you spread out the data over the double of servers, which means every single server, every single Postgres database on this segment host has to do less work. Will be faster. Okay, what problems does it solve? It can do OLTP queries, but you don't really want to use it for small little OLTP queries. You actually want to run any kind of large-scale analytics on it. Gigabytes, terabytes, maybe even petabytes of data to scan. Your typical reports overnight, over weekend, business reports, this kind of stuff. Your central data warehouse in a company where you move all of your data from all the different departments you have into one database and then run all of your reports on it. This is a typical use case for shared nothing data warehouse like WarehousePG. Anyone knows what this number is? On the bottom right? That's a petabyte, and it's a single table. No partition, just one table. Can you do that in Postgres? Well, you have a hard limit in Postgres of 32 terabyte for a single table. And because I can scale this up over multiple Postgres databases, I can actually go and run a petabyte on it. And thanks to Tom over there, he challenged us last year, show me that we can do a petabyte in WarehousePG. Well, here we are. Thanks for that. Okay. So where do we position Postgres and WarehousePG? Everything which is OLTP, you have your small data sets, relatively small data sets, couple gigabyte. Anything which is sub-millisecond, you better use a Postgres database because it's faster. An OLAP database like WarehousePG, everything which is larger than your typical Postgres database. Everything you won't fit into one single server. It's better positioned for WarehousePG. On the other hand, you can use the same drivers, same applications. You just point it to a different database now. It's still a Postgres database upfront, except you get a better performance because your queries run faster. And then you get a data warehouse, which is your central source of truth in a company. So you don't want to have like 5 different departments, production and finance and legal, having their own databases and then run their own reports without taking all the other data you have in a company into account. Instead, you move all of the data in one single data warehouse, and then you run all of your reports on this one data warehouse, combined over all of the data you have. We have something which we call hot, warm, and cold storage. So kind of like in Postgres, you have an external table or a foreign data wrapper. We have a concept of called external tables, which allow us to position the table, an external table, or like a CSV file, or an external data source, or an external application, as a table in WarehousePG. So for the database, it looks like this is a table, like any other table you have. But instead of having the data in my data warehouse, I query my data wherever it lives. This can be a different BI application. This can be a CSV file somewhere on a cold storage because it's cheaper. Basically, anything you can imagine can be a table in WarehousePG. This goes a little bit beyond what we have in foreign data wrappers in Postgres. And we can make this table a partition of your other table in WarehousePG. So what you can actually do, you have like finance data for 10 years. In the current year and the last year, you have in your data warehouse, and then you move the other years out to a cold storage, NAS, whatever you have, and you query this data using an external table in WarehousePG. You don't have to change your application. You don't have to change anything. You just change the table presenting this data from a regular table to an external table, make it a partition of your regular table. No change at all. All of this gives you a lower TCO in total. WarehousePG is open source, so you can just go and build your own database from it. We actually just published last week a Docker repository, which shows how you can build WarehousePG on your own, if you want to do that. We're also talking to a couple customers who want to do that on their own, so they don't actually want to have packages from EDB. You're also free to just build your own packages around it. And we as EDB, we provide RBM packages on top of that. We also have in database machine learning. So PG Vector is supported as an extension. PG AI we have built in. There's also a library called Apache MADlib or MADlib, which is around for 10, 12 years already. It supports both Postgres, Greenplum, and WarehousePG at this point. Good, but I'm here to tell you what happened to Greenplum. Anyone ever worked with Broadcom? A couple people. In 2015, I was working for Pivotal at the time. We made a big announcement, beginning of the year. Pivotal is making all of their products open source, everything they had. Redis, Hawk, Greenplum, a couple more. This was in February. And then in October, we announced that Greenplum is now finally open source. Why October? Well, it nicely happens with the Postgres conference in Europe. So we timed it for the Postgres conference in Vienna. What happened in between? Greenplum is a Postgres fork, but it was closed source for 15 years back at that time. So if you develop a closed source product, you have all kind of history in your commit logs, and they merged from Perforce to Git at some point. There are customer names in it. There are things in it you don't really want to publish. So we had to actually go in and clean up the history, remove everything which is not supposed to be in open source. We had to check for patterns. That's why we choose the Apache license over the Postgres license, because the Apache license gives you a protection against patterns. We had to rebuild the entire build system we had, find a governance model. So how is this Greenplum in open source steered? And yeah, we had to find a release date. And quite early on, we targeted the conference in Vienna, which gave us about 6 months to make this happen. Back then, Greenplum was based on Postgres 8.2, which was already 6 or 7 years behind. Over the time, up to 23, it got updated to now it's version 12. It's still a little bit behind, we're working on it. But it took some effort to go from 8.2 to 8.3, about 3 years or so, and then they merged later versions. And then 22 happened. This company called Broadcom announced that they're going to acquire VMware. Why was it bad? Because at this point, Pivotal, the company owning Greenplum, was already acquired by VMware. So now Broadcom is getting hands on Greenplum. And anyone who ever worked with Broadcom before knew that not good things are going to happen. This was 22. The transaction closed about 18 months later because there was some discussion in Europe. And then in May 24, Broadcom announced, okay, Greenplum is now closed source. Out of the blue. No announcement, no nothing. They shut down the GitHub repositories, they shut down the mailing lists, they deleted the Slack they had for Greenplum, deactivated the concourse pipelines, all gone. The other thing they did is they actually started hiking prices for customers. From what I've seen and heard, it's sometimes 3 times, sometimes 5 times more expensive. So customers are not really happy about it. Another move they did, they shut down the repository on May 24, and they removed all branches and tags. So all what was left after May 24 is the main branch. And well, you have the commit history, but you don't know at which commit was like version 6 released, or 6.1, or 6.2, or whatsoever. All of this is gone. So even if you want to use Greenplum and build your own model, you don't know what you're based on. All you have is the commit history and nothing else. Well, this was the first challenge we had in Enterprise DB when we started looking into this. So there's no release information, there's no tags. What they most likely did is they copied the repository and only copied the main branch. That's why there's no tag information, no nothing. So this repository is useless. You can't really do anything on top of it. Well, what are we going to do? Tom got me on board back then to look into what are our options to actually work on this. As I mentioned before, we looked into Cloudberry, working with them. By the time they were already on Postgres 14, but there's not a lot of activity. So if you go and actually look at the commits in the Cloudberry repository, there's not a lot going on. So that's not an option. We looked at other repositories out there on the internet, on GitHub, GitLab, couple other sources. There are forks of the original Greenplum repository, but legal says you can't really use this. We don't know what this is. We don't know what's behind the account name. We don't know if the history is complete, so no. Well, there's also one repository we found. It's called GPOL Enc. And if you worked with Pivotal, you know this is the Pivotal release engineering. They had their own GitHub repository and GitHub organization. And no one was doing anything in this repository anymore. Well, probably by this time, anyone who had access to it was gone from Broadcom. Just dormant. But it had all of the tags and releases. Yay, good for us. Well, until we talked to lawyers, and they said, no, you can't really go and use it. But you can import the tags into the other repository. Well, if you know Git, one thing is the same as the other. If you import tags, you get the same code. But for legal reasons, we can't really use this. So what you will do is at the release engineering repository, fetch all of the tags, remove the origin, and then you have all of the tags in your main repository, which we forked from the Broadcom repository. Except the way Broadcom forked the other repository, they removed all of the tag information, and along with the tag information, they removed all of the code, which is not necessary for the main branch. So by importing all of the tags, we actually imported about 20,000 commits into our repository. Not good. Okay, we went back to our lawyers and they said, okay, prove to us that anything which is in this repository is not malicious. Yeah, we know it's the release engineering repository. Yeah, we know maybe no one has access to it anymore. Well, we want to have hard proof. So we used this approach using the release engineering repository, and then we checked all of the files in it against all of the other repositories we found on the internet. We documented the entire process, so if you go to this URL, you find how we did this. And all of this matched. So every commit, every tag, every file we found was matching across all of the repositories we found on the internet. That was good enough for the lawyers to say, okay, you can go and use that. So what do we have today? We have a fork of the original Greenplum repository, the main one from Greenplum. We imported all of the tags from the Pivotal release engineering branch. Along with it, all the code. So we have the 6 and the 7 Greenplum release, WarehousePG release now, which is what customers are using today. We have no CLA, contributor license agreement, on it, because for all the existing code in Greenplum, Broadcom has the CLAs. So we as ADB or anyone else forking this repository can never go and change the name or the license on it, because you're missing all of the CLAs for the existing code. Why bother? Good. Broadcom was in their rights to make it closed source because the Postgres license on Greenplum and the Apache license actually does allow it. It's a BSD license. You can just go and say, okay, I made it closed source again. And the BSD license by itself does not force you or require you to publish the source code for your application, unlike the GPL license. The same license allowed us to fork it and make it open source again. So two can play this game. Now the project is alive. We have a couple committers on it. We have more contributors on it. We're constantly making bug fixes to both the 6 and the 7 version. We're releasing RPMs for it. And we have customers betting on us that we can do better than Broadcom did with them. Okay. Where are we going with this? Right now, ADB is providing RPMs for Red Hat. So any Red Hat branch like Fedora or Red Hat server you can use on this. We are not providing Debian packages as of now for the simple reason that no one asked. We know that Greenplum back in the day provided Ubuntu packages because there was requests for it, but we haven't got any. If someone is asking us, we are most likely going to do it. We also do black duck scans, so we try to identify any kind of risks, known CVEs, etc. in the code. And everything we do for the black duck scans goes back into the open source repository. So we don't maintain an internal repository with changes for customer. It's all out there in open source. We also do code analysis scans using SonarQube. So that's built into our pipeline by now. Anything we find there, again, goes back into open source. We have CI pipelines open. So Pivotal back in the day did use Concourse CI, if you heard about that before. It's a nice, shiny interface with a lot of animation. We don't really want to use that. We plugged it into GitHub workflows by now. And all of the tests we had in Concourse CI are now in GitHub workflows. We're working on observability, we're working on backup tools, because both observability, Greenplum Command Center it was called, and the extended backup tools are closed source as well. So Broadcom just took the repositories, made it closed source. We are working on high availability, and yes, we're also working on kernel upgrades. So we don't want to get stuck on Postgres 12. We want to get to a higher Postgres version, but that's a lot of effort. Another problem we are trying to solve with the kernel upgrade is the driver and application compatibility. So if you look at WarehousePG today, it says select version, Postgres 12.12, WarehousePG 6 or 7, which is both good and bad, because if your application actually checks the version strings, it sees, oh, that's a Postgres 12. I don't support it anymore because it's end of life. Not good for us. We know we have all of the bug fixes in it. We know we have all of the features in it. Still, if you only check the version string, doesn't help us. One main reason why we want to do the kernel upgrade as well. Well, you can have stickers if you come to the EDB booth later. I have a full pack of WarehousePG stickers for you. Grab some.